And thank you, Leon. Good morning. I'll try to be clear, but if I'm not, please interrupt me and tell me, because I haven't practiced speaking English in some time. CSPP, GEO, and LEO use at the National Laboratory for Earth Observation, LANOT, Mexico. This laboratory is national because it's sponsored by CONACYT or science like NSF in here, government science supporter. We receive, store, process, and distribute remote sensing data and images from issuing alerts on storms, wildfires, volcanic emissions, as well as continuous surface and atmospheric monitoring and studies. This is the working area in our laboratory, and we also have a small data center with a storage system, currently 1 petabyte. This several processing servers and distribution servers. We distribute data by FTPS and web. We have 3 stations to receive joint polar satellite systems, which is this one round because the antenna is moving according to the position of the satellites. A GeoNetcast, this small one, the GeoNetcast system to get data, and of course the GAUSS 16 system. We provide data and products to several government agencies and universities. For example, CENAPRED is the National Center for Disaster Prevention. CEMAR is the Sea and Ocean and Sea Agency. And these are other universities and the Weather Service, the Meteorological Service, and so on. CONACYT is what I was telling you, is the agency to support science in Mexico. Like NSF, no? Is here, or something like that. Our use of CSPP GEO, we use intensively CSPP GEO for several products. True color and night view, that an example is of course this one, is very required by our users. Also, hotspots detection, fire, lighting monitoring, the Saharan dust that comes every year by June, comes from Africa to Mexico, and volcanic ash. This is just 5 examples, but they are not the only ones. We create the true color daytime using a combination of the 3 first bands from GOES. The green, of course, is synthesized green using these bands. And we are also using GeoGrid from you to do this. And for the nighttime pseudo color or false color, we use the band 13 to get the bright temperature from the clouds, combine it with NASA's city lights, and we have this, I think, beautiful combination, this composite. We use a lot the CONUS because almost all Mexico is included in CONUS. And every 5 minutes we get data. And we also create some other codes, like this one that includes part of Central America and South America. And One of the first applications is detection of fires, wildfires, vegetation fires. This is from a paper submitted to the Remote Sensing Journal. This is just a description of the algorithm. When we get bands from GOES, from ABI, and combined with other satellites, beers, and that, and we can identify potential pixels of hotspots. Here is a comparison of some other systems. Our algorithm is these like diamonds here, and you can see that it works not so bad, no? Here are the plumes of the fires compared with these other systems. And by the way, Lilia Manso sends greetings. She was also in the workshop. Sends greetings to the CSPP team. This is the hotspots localized in the map. And using our algorithm, and at night. Now monitoring the electrical storms, we use, of course, GLM. This is just qualitative, where are the flashes detected. And this is an animation that we show in our page every 5 minutes. And, well, this is not the animation, but this is just a shot, screenshot. And we, early this year, in January, we started to use the new products from CSPP 80IF2 Beta 4, grading products of GLM. And these several agencies, several of our users ask for this product, so we are distributing it. The Saharan dust. This was a Friends conference 2 years ago, because it was a particularly strong storm from Africa, and you can see here the sand coming from Africa to Mexico. And we did this in combination with Dr. Luis Antonio Ladino. And it usually is good, this sand, because it has a lot of nutrients that are good for the vegetation. So actually, we don't complain to Africa for sending that dust. And these are some products that we made. Here is clear, no? The dust traveling all the Atlantic Ocean, traversing all the Atlantic. This is a pseudo color, magenta. The dust can be identified with the magenta color. And this is CSPP dust mask. So, we are, every June, we are doing these stories about the dust. Volcanic ash. By the way, we are using some reference from Povolonis. And this is we call, do you remember how we call this volcano? The Popocatépetl? Dongoyo. There is an active volcano near Mexico City. And here, if I have time, I can show you the animation. This is here is the Popocatépetl in an active eruption, and the colors mean ash. The red is ash, and probability of ash is the orange. This is a code for probability of ash. The red is that we have actually ash. This is an algorithm, I think, based mostly in Pavaloni's papers. But now, when you went to the workshop, we were not using much LEO at that time, and we started to use a combination of IPOP from NASA and CSPP to get these products. I will show CLARP, ASI, flood detection, ACS-PO, and of course polar to grid to create views. From the, from the more modern satellites, NOAA 20 and those, we get these products. L1 products from Beers, Greece, ATMS, OMPS, and L2 also, no? 62 products from Beers, L2. These are examples: true color, phase, cloud mask, aerosol particle size, suspended matter, aerosol optical thickness, cloud top temperature, cloud optical thickness, cloud effective particle size, NDVI, the vegetation index, and land surface temperature, active fires true color. Obviously, we should zoom this one to, here we have you can see the plumes, no? The smoke. And here. Surface reflectance, and flood. This is I also showed this example last time. This is the biggest lake in Mexico, Chapala Lake. And the red is that it's growing the lake, which is good. In the ocean, what is this? Temperature, no? SSD, I guess. And this is also vegetation, no? Aqua and Terra, we also get data from older satellites. And this Aqua and Terra, using CSPP and polar to grid, we get 4 L1 level 1 products and 12 level 2 products. And from the older NOAA satellites, 15, 18, 19, we get CLARP RX, ACS-EO, and polar to grid. Polar to grid are the views. So, level 1 product in ABHRR, AMSUA, 2 products, AMSUD, 2, and HIRRS, 3, and HBHRR ABHRR 12 level 2 products. From the top, 1 to 3. We have also 12 level 2 products and some other level 1 products. And I don't know if it was too fast, but the conclusions. We use CSPP, low Earth orbit, LEO, and geostationary, GEO, for the generation of important products needed by our users nationwide. We will continue using and updating the CSPP packages in our processing servers and developing derivative products. And this photo is from the workshop. I guess you can recognize some faces here. So.
Thank you, Alejandro. Gracias. Muchas gracias.
Thank you.
Do we have any questions for Alejandro? Yes, we have.
Thanks, Natasha, for your presentation. Just really quick comment. So it's great to see that you're using a lot of LEO product in your CSPP applications. I'd love to learn more. I see you showing all the LEO product images. I want to learn a little more about how they are using in your applications. You use LSTs, if it's reflectants and ocean products. I want to learn more how they support your applications and your operations.
Yeah, sure.
You can talk about that. Thank you.
Yeah. I think I put some some IPs, some web addresses. Yeah. And our main, it's not here, sorry. But I will send you by email. No. Yeah.
I think Leon said she'd be happy to have that discussion offline as well. So we can do it after the presentation.
Yeah, sure.
Next question.
Yeah, I was wondering, do you use the mesoscale? Do you order mesoscale sectors from your institution? If you want to do this,
Very good question, because usually those are very particular situations, mostly here, no? When you have cases like the fires and that. And we, in one occasion, that with a hurricane that was very close to Mexico, we also used the mesoscale parts, yeah. But usually, no. Maybe we should use more, if possible. But yeah, we had using, I think, once, 2 years, not before the pandemics, with that. I don't remember the name of the hurricane right now, but I will send also by email.
Alejandro, your GOES ABI comes from GRB, correct?
Yeah.
Okay, so whatever's on GRB that day, that's what they're going to receive.
Yeah. Yeah, we could request. And I think we haven't done that. We should. Yeah.
So one of the things I think that's so appealing about your system is that you have, I remember talking to Gabriella years ago at a satellite meeting. About, can you hear me okay?
Yeah.
About this concept that you had. That you would have a GRB antenna, and you'd be sending it out to all these groups within the university, and you showed the map for the diagram of all the groups that are getting the data. And really, to me, that's really what direct broadcast should be about. And, GRB antenna is not all these different groups that are using it. So how do they get access to the data and products? Is it they have to come to a central like water pool, or is it actually distributed to these groups? That's a lot of data.
Yeah, well, for registered users, they use FTPS. We have a 10 giga connection, 10 giga network, and they can get the data by FTPS. For example, Senapred is continuously downloading data. We are not unique, as you say. It's not too expensive to put an antenna for the GOES, but we also produce products, no? We distribute them, not just direct that L1 products, no? Yeah.
Good. Thank you, Alejandro.
Thank you.